Okay, so we're going to move into solving trigonomic equations. We will be solving first degree trigonomic equations today, and then next week we'll look at second degree. So what first degree trigonomic equation means is it just means that your trigonomic equation only has an exponent of 1. A second degree trigonomic equation would be something like this, where your trigonomic equation has an exponent of 2. All right. So let's actually start looking at some questions because that's the best way to learn this. When you're solving a trigonomic equation, you do want to make sure that you pay attention to the domain that the question is asking for. A lot of these questions, you can use a lot of different strategies to solve. You could use the castrol. So let's start off drawing this angle. So we know that sine is negative if I use the castrol. I know the ratio, sine ratio is negative in quadrant 3 and quadrant 4, so I'll draw that out. So I know that those are where my angles would be. Okay, I could also use my unit circle. Your unit circle is super helpful and you can go through the problems really quickly. Okay, so if you use your unit circle, you will notice that, and remember on your unit circle, your ordered pairs are written as cos theta, sine theta. And you know what? I'm even gonna quickly see if I can go back to a unit circle. I'll be fast. There it is. So we know sine theta, which is our second in the ordered pair, second point, is equal to negative 1/2 at 7 pi over 6 and 11 pi over 6. So guess what? That's our answer. So I'm going to go back here. And I know my answer, x, or the angle, is 7 pi over 6, which is this angle here, and 11 pi over 6. Okay, and I just want to double check, are those angles in my given domain? Yes, they are. Okay, and now the second way I'm going to double check this answer is actually by graphing. So, take out your graphing calculator. Just like any equation, you can graph because you have two sides to the equation. So we have angles in radians, so that means we need to be in radian mode, which I am. You just type one side of the equation, so I'm going to type sine x into y1, and the other side of the equation to y2. Now when you're graphing, the domain is actually super important because you're going to set your window to the domain in the question. So my domain is from 0 to 2 pi, so I'm going to make my x-min 0 and my x-max 2 pi. Okay, and I'll just leave the y the way it is. Awesome, and then we can see our two intersection points. So we'll go to second calc, intersect. And as I've mentioned before, your calculator won't do the left bound, right bound, so it's actually easier on yours. Scrolling. Okay, so there's my left side of the intersection point and my right side, and my answer is 3.665. So your graphing calculator won't give you the exact answer, but it's super helpful when you want to double check. So let's type in 7 pi over 6, 3.665. So we know that it's the same answer. So we know for sure that we did that correctly. So the graphing calculator will give you the exact answer in degrees, but in radians, it's just a really good tool to double check and make sure you did it correctly. Okay, let's keep moving here. So now my next question, I have secant. So first I'm going to isolate that secant. That'll be my first step. So I'll move the 5 over, so it becomes positive 5. And I'll divide that 3 over, so I end up with 5 over 3. And I know secant is the reciprocal of cosine theta, so I'm just going to take the reciprocal of that ratio. And now I can draw it. So I know I have a positive ratio, and I know cosine is positive in quadrant 1 and quadrant 2. So obviously this one isn't on the unit circle, so I'm going to have to use the castrol and my graphing calculator. So to do that, I'm just going to type in, because I'm trying to find an angle. So whenever I want to try to find an angle, first of all, I need to go into degree mode because I'm looking for my angle in degrees. And I'll type in second function cosine 3 over 5 and I end up with an angle of 53. We'll just round it to the nearest whole for right now because the question doesn't specify. So we have 53 degrees, and we know you'd be using the Castrol that this angle in quadrant 4 will have a similar reference angle of 53 degrees, which means the principal angle would be 360 minus that 53, which would give us a principal angle of 307. So there's angle 1, angle 2. So you may be asking, well, how do I graph this? I honestly would graph after I rearrange, just because there is no button on your calculator for secant x. So I would rearrange the equation first and then graph at this point. Okay, so we've already talked about how to graph, so I'm actually going to skip these next couple problems, and we're going to look at one very similar to this, so we'll skip those. Okay, so let's just practice with some different domains because that's pretty tricky for kids. Same step, you're going to start with the same step, by isolating your ratio, your trig ratio. So I'm going to move that root 2 over so it becomes positive, and then I'll divide the 2 over, so I end up with root 2 over 2. Okay, this one is nice because I should see this on my unit circle, root 2 over 2. That should be a familiar ratio. If you didn't recognize, you could still use the Castrol just like we did in the last problem, and that's fine. Actually, I think I'll do that. So I know sine, here's the Castrol, but this one would be easier just to spot it on your unit circle. Okay, so sine is positive in quadrant 1 and quadrant 2. So I can just type in, and I should still be in degree mode, second function sine root 2 over 2. Enter, and I end up with 45 degrees. All right, so I have an angle of 45 here. Okay, and then I should have a similar reference angle over in quadrant 2, which would have a principal angle of 180 minus 45, which ends up giving me 135. Okay, so here's the tricky part. We're not actually finished here because these two angles are not in my domain. Okay, so what I would do now is I would use coterminal angles. So I really know this is just one rotation. So I want to take this 45 degrees and figure out the coterminal angle, which is one rotation from 45. So really all I'm going to do is add 360. So if I add 360 here, I'd end up with 405 degrees. If I add 135 to 360, I end up with 495 degrees. And I would like to really quickly show you how to do this on your calculator as well. Okay, so we should still be in degree mode. So you could type it in after you rearrange it or before, it doesn't matter. I think I'll do before I rearrange this time. 2 sine x minus root 2. Okay, and then the other side of the equation is just 0. So remember, your window you're always setting to the domain in the question. So the domain in the question this time is from 360 to 720. Okay, and then we're going to graph it. So there's my two intersection points. So I'll go second calc, intersect. My cursor's way over to the left. I have to keep moving it. Hurry, cursor. Man, this is taking a while. Oh, there it is. Okay, left bound, right bound, and I end up with an answer of 405. So that's why the graphing calculator is so great to double check any type of equation. Okay, we will try this one too just because of the different domain. So first step, again, rearrange for cotan. Okay. So I end up with a ratio of -1 over root 3. Okay, and then I'll take the reciprocal of that ratio. I know cotan is the reciprocal of tan, and I end up with -√3 over 1, which is just -√3. I will draw this out. Okay, and I know that tan is negative in quadrants, I'm going to use a different color, 2 and 4. Okay, and then I'm going to try typing this in my calculator. So now my question is back in radians. And I sometimes have kids who like solving all the angles in degree mode and then converting it to radians, and that's fine. It's not a big deal. Okay, so I'll go second tan negative root 3. Okay, and I end up with negative 1.04. Now I'm going to check this to see if I can answer as an exact value. So does this have pi units in it? So to check it, I'm going to try dividing it by pi. Where is my pi button? There it is. Awesome, it does, right? Because that is the same as negative 1 over 3. So really my answer is negative pi over 3. Great. Okay, so I know then my reference angle has to be pi over 3. So let's look at the domain here. Our domain is from negative pi to 0. So really, we're just looking at this part of our graph here. So actually, that's my answer, negative pi over 3. I don't even need to find the other angle because it's outside of that domain. This is another one. When you're given a different domain like that, especially with negative angles, I would double check it by graphing it. Okay, here's a diploma question. I'm actually going to get you to try this one by yourself. I will give you the answer, however. So the answer is D. See if you can figure it out and double check it, but it's exactly like the same types of questions that we've been working with. The only difference is this time they asked for the general solution. So I am going to talk about that. A general solution, remember, is when you need to find the two principal angles. So you would find the angles between 0 and 2 pi. And those would be your angles. And then the general solution you would just write as an expression plus 2 pi n, where n is any integer. Okay, the last thing I want to show you is just something quickly on your graphing calculator, which deals with multiple angles, but we won't dive too far into multiple angles. So let's try, I want you to graph this. We're going to stay in degree mode here, and we're going to graph cos x equals negative root 3 over 2. Oh, I'm in radians, so I got to go to degree. Okay, so I have cos x, and then on the other side, negative root 3 over 2. And then I'm going to set my window to the given domain, which is 0 to 360. So x min is 0, x max is 360, because that's the domain in the question. Graph. So there's my two solutions there. Second, calc, intersect, and my cursor is like way over to the left again. There it is. Okay, so anyways, you're going to find the intersection point, which you know how to do on your calculator, and you should end up with angles of 150 degrees and 210. So if you wanted to write a general expression, you would go 150 degrees plus 360 n, where n is any integer. And then you would do the same for that other solution. Okay, so you need to write a general solution for each of those answers. Perfect. So I have two general solutions because I have two principal angles between 0 and 360 that have this ratio. So now I want you to do the exact same thing, except for this time you have a b value of 2. Remember what we learned about the b value way back in the first unit? That's a horizontal stretch of 1/2. So what we should see is that our graph, which originally would look something like this, it's going to be horizontally stretched. So all of my x values are going to be times by 1/2. Okay, so I actually should see double the amount of solutions. Let's see if we see that. So we're going to go back to y equals, and we're just going to fix that 2 to 2x. Perfect. So we should see 4 solutions because what ended up happening is that entire graph was times by 1/2. It was horizontally stretched by 1/2. Okay, so now if you were to find all those solutions on your graphing calculator, they would be 75 degrees, 105 degrees, 255 degrees, and 285 degrees. So what ends up happening is this 150 was cut in half to give me that solution of 75, and this 210 was also cut in half to give me that solution of 105. So the last little step that a lot of kids forget is not only were your solutions cut in half, but the period of your graph, because the entire graph was stretched by 1/2, the period of the graph was also cut in 1/2. So now instead of plus 360, we have plus 180n, where n is any integer. And then we'd use the other angle as well. And you might be asking, well, how come I don't have to write it for all 4 angles? You don't need to, because this is just the next rotation. Like if you were to take 75 and add 180, you would get 255, because that's the next rotation of that angle, the next coterminal angle. All right, so we're going to stop there. I just wanted to show you multiple angles and kind of how they tie into horizontal stretches, but we won't continue. So you don't need to practice the multiple angles. I would say just make sure you understand how to solve trigonomic equations both algebraically and graphically, because we are going to keep building on this. So it is a very important concept moving forward.